All right. So this is trust issues in networking. Everybody might have fun grabbing this. It's basically just a Reveal.js presentation and all the raw PCAPs from the technical part. There's also a README on the front where we have a couple little tips and tricks, some of which can be somewhat useful. There's a down and dirty SSH trick if you don't have a VPN provider available. There's a little test for what version of SSL does the server support, etc. And then some links to some stuff that we were was on our minds when we were making this. So I'm Trevor Rosen. I'm here on the top level. We have Todd Beardsley here. We have Egypt. I was going to make a joke that his last name is not Beardsley, but I will not make that joke. And we all work on a product called Metasploit, which is also an open source project. And you might recognize this from meetups here and there and from this space before. And we have been to and have given, I think, a lot of talks over the years to developers who don't work explicitly in security. And it kind of occurred to us that most of those talks are, for one, not very long on like decent in-depth knowledge of like what's going on in networking. And two, they're all very kind of negative. They're all sort of predicated on like, be afraid, be paranoid, like cover your ass, but your ass is going to catch on fire anyway. Like you can't do anything about it. Be afraid, be paranoid. Which is not to be denied. There's definitely quite a bit of that in the world. And even a little bit of that in this talk when Todd gets up here in a little bit for the demos. But we wanted to sort of back up and try to frame all of this stuff in a way that sort of makes sense and is maybe possibly a little bit more positive as as an audience of developers might find it. So just to note real fast on the structure of this talk, it's going to be kind of two sections that are on either side of something that's not a demo because it's definitely slideware, but it's sort of a technical deep dive. So if you have questions during the technical deep dive, we would love to answer those, but please hold them for the end because I think after this talk's over, we'll take a little break and then come back and then have kind of an unfettered question and answer session. We had been sort of advertising that as part of this. No question is dumb. Anything you've got on networking or security or whatever, if you want to stump the experts, that's them, that's not me. Just to get that out of the way. So yeah, let's get started. So first, before we talk about trust on the internet, we have to talk about like what is trust in real life, like how does it work, right? I'm going to use the term meat space, sorry if that offends anybody, but trust in meat space society, us, day-to-day interacting, just like we are sort of here right now. Back in the time when everybody was like coming up with the ideas behind basically what would become science, some people started thinking about like how societies worked. And it makes sense if you think about it, right? Like some people were getting together and saying, hey, I can observe like phenomena in the natural world and I can think about those in a structured way and I can like kind of come up with scientific discoveries. That's really cool. Well, there were people that were thinking about like how societies actually function at the same time. Wanting to know like if there are kind of axioms in mathematics and science, et cetera, are there any about like how people interact? And these people all had different theories, but all of them basically agree at a certain point that without society, mankind exists in what they call a state of nature, right? I mean, just everybody running around killing each other willy-nilly, right? Hobbes famously described it as nasty, brutish, and short. By the way, I did not get a philosophy degree, so you guys feel free to take me to task at the bar later on about anywhere where I'm wrong here. But the basic idea of a state of nature is that pretty much it's everybody for themselves, kill or be killed constantly, right? Like, so your life is basically just a constant struggle for survival and search for food, sort of like the basic state that most animals are in. But that's not the way that we live, right? Like whether we live under kings or dictators or some type of democracy or, you know, the tribal shaman or whatever it is, we all live within some sort of structure. And so all these social theorists, they all sort of universally have this concept of a social contract. And the social contract basically says, I will give up some of my freedom. And keep in mind, in a state of nature, I have perfect freedom, right? Like I can walk up and like hit Todd in the head with a hammer and like there's no cops, right? Like maybe Todd's family would like avenge him, but like, or Egypt might, yeah, we would hope. But you know, there's no sort of like societal structure like preventing me from like running up and hitting Todd in the head with a hammer. And so in a social contract, you are giving up some of your freedoms, i.e. my freedom to hit him in the head with a hammer, in return for being able to live within some sort of social fabric, some sort of structure of laws and rules, et cetera, that kind of keep things from dissolving into complete chaos, right? So all of these hot thinkers have these conclusions. So I have all these notions of social contract, and they come to a set of different conclusions. And like for me to paint all of these people, like, you know, Locke and Hobbes and Rousseau and Kant all together as the same is really doing them a disservice. But again, this is not a philosophy class. So overall, what are the conclusions of social theorists over time? I'd say humans are incentivized to behave. Like, no matter what, at a certain point, like, there are really three kind of specific frameworks that form the basis of all the laws and sort of basic societal strata that we have today. So everything flows from them, right? So like, let's think about murder, right? We've got the moral reason not to kill. Don't kill because it's wrong. Or like the sort of religious flavor of that, it's harmful to your soul or your karma, right? Reputational reason not to kill. Don't kill because you'll be ostracized. You're a dangerous murderer, and now the people around you are going to like force you out of the village or the tribe or whatever, right? The cooperative reason. Don't kill that person because maybe you can like team up and do something more than you'd be able to do on your own, right? So these are the sort of axiomatic things that we have in society that help us kind of come up with a big overarching framework that we use to do all these different types of things. And no matter what kind of society we have, everything at some point in time is going to come back to one of these kinds of frameworks. So to boil it down even further, Kant came up with this thing called the categorical imperative, which basically says, treat human beings as their own means, not as a means to an end. And you can kind of go and look at any sort of thing that tends toward abuse of power and say, well, this is usually someone starting to treat human beings as a means to an end instead of an end in of themselves. Right? So he has this sort of real fancy way of basically reiterating the golden rule. So we've got all these motivations and morals. Political philosophy gives us some. We get some from psychology about how individuals behave. There's this field of sociology about how collective behavior works. And so we've been able to come to a whole lot of conclusions. But is that it? I mean, is the sum total of what we can know come from those three things? Actually, no. We actually have game theory too, which is really interesting. We have two squirrels over here, and they have different ways that they might, you know, share or not share or whatever, right? Probably everyone in here has heard of the prisoner's dilemma, which is, I'm sure, is probably the most famous notion of like what a game theoretical construct is. And like the prisoner's dilemma, we can do experiments. We can find out sort of and kind of tune experiments into situations, find out exactly when it would be that somebody decides to not act in their own best interest anymore, but to defect. Defecting means, or not act in the collective interest anymore, but to defect and act in their own. So defection is this notion in game theory of a human actor deciding that it's become no longer, the incentives have changed to the point where it's no longer in their favor to act in their own best interest. I mean, to act in the collective interest, they're going to go ahead and do their own thing. Okay, so why does all this matter? Like, this is Austin.RB. We talk about Ruby. We talk about computer stuff. Like, why am I up here boring you with like, you know, things that people talked about hundreds of years ago? And the reason is that on the internet, defection happens much more quickly than it does in really anywhere in society, right? We don't have this social contract because there is no overarching thing that we're all opting into or born into or whatever that creates what we think of as a notion of society. There aren't the same kinds of constraints on behavior. The ways that we sort of have cues and interactions, like through morals and cooperation and reputation, don't exist the same way. In other words, there's really no consequence for acting like a sociopath. Sociopath's a word that gets thrown around a lot. So I thought it'd be useful for us to take a look at some of the indicators as published by Wikipedia, because I think we might recognize some denizens of the internet here. Failure to conform to social norms, lying, use of aliases, conning others for personal profit or pleasure, impulsivity, irritability, aggressiveness, consistent irresponsibility, lack of remorse. I don't know if people follow like the various ways that like people are evilly and horrendously harassed on Twitter, but recently we were all treated to this bizarre thing that everyone named Gamergate. And you see lots of people just sort of getting onto Twitter, creating throwaway accounts, and just going nuts. And they're doing things that, by and large, those same people would never do in society. They would feel constrained by the need to do this face-to-face and would back away. Not to say that there aren't dangerous people doing this and saying these things as well, but the internet doesn't have, like I said, any of the same types of constraints. So it can be filled with people who, even if they're kind of relatively normal in their normal lives, on the internet manifest as thieves, trolls, and perverts. And it sounds really depressing for me to talk about the internet that way, but like, it's only depressing if you think that it should be like human society, despite not having any of those things. It's useless to try to understand the motivations of people acting outside of any familiar framework for human motivation. You can really only react to it because eventually you're going to encounter people that are just like awful and you have no way to explain them, no way to reason with them, like there's just nothing you can do, right? So if that's true of trust, and that's how trust in society comes about, is that we have these frameworks, and then on the internet it's loosened. How do we trust on the internet, right? I mean, more importantly, without a social contract, how do we actually avoid trust on the internet? Because it sounds like trusting is bad, and it's not something that we want to do. But the real answer is that we don't. We will absolutely never have total control, right? Like, I'm sure that because of Austin's ongoing and no doubt infinite public transit woes, most people probably got here today by driving a car. If you drove a car, you were probably separated by a group of other completely lethal objects by nothing more than 2 painted lines. The reason that you didn't get into a head-on collision with all of those people is those people are incentivized not to hit you, right? I mean, at some point, trust is inevitable. You're just going to keep going, you're going to keep driving, you're going to say, hey, like, he's got a reason not to hit me, I've got a reason not to hit him. Again, those things start to get loosened on the internet. And at some point, though, trust is inevitable on the internet just as it is in society. You're going to have one of those two-way streets, right? But we should know where we're trusting. We should understand what sorts of chains of trust are created as we move around through the internet, as we do the things we do as developers. And we shouldn't trust any more than we need to. Again, people find this idea depressing. I sometimes encounter people who tell me, well, I want to trust more. I'm a trusting person. I want to think of myself that way. And this is not like a bad idea. You know, this is something that lots of societies value. This is something that's valued in many religions. This idea that you can be a trusting person and that you know, trust and karma and all these other things are all kind of intertwined. And that's great, but it's not what we're encountering every time that we're on the internet. Again, and I can't drill this home hard enough, the internet is not the same as our meat-space society. Like, we don't need to lament that. We don't need to try to change that. The absolute sort of human physics of it are completely different. So given that, what are our tools in a trust-diminished environment, right? How are we supposed to operate in this world of not being able to do very much trust-wise? We have encryption, which enables us to make sure that we can talk to each other in a way that's secure, it's not tampered with by somebody else, that the message I send to Todd is the message I intend to send to Todd, and is not the message that like somebody else messes with on the way to Todd. We have authentication, so I can find out that Todd is Todd, and he can find out that I'm me, and we can talk to each other and feel good about that we're really sending the message to the right person. We have vigilance, which is just about sort of best practices, keeping abreast of what's going on in the world in terms of the tools that we use and the libraries that we bring into our apps and those kinds of things. And yeah, we've got faith. Yes, faith. Because like I said, at a certain point, you've got to depend on others. And you're probably trusting things more than you think. And again, knowing when you're relying on faith is paramount, and knowing at what every step in the whole chain of things that you do on the internet, what is faith predicated, is something that we're going to explore actually right now in not quite a demo, because demos tend to not ever work. So this is going to be a demo with like screen captures basically. So Todd's going to come over here and run the first of a couple different deep dives into like what's going on when you use ATT Wi-Fi at Starbucks. And come on up, Todd. Let's do it.
All right. Cool. So, like Trevor said, this is kind of a deep dive on basically what happens to your computer, your phone, your iPad in the first 2 seconds or so of waking up, of getting power. And we're going to dive into this because, like Trevor said earlier, when we go to developer conferences, most of the time it's very language oriented. Everybody's talking about Ruby or Node or Go or something. And kids today, you know, they don't build their own computers like from the metal up. You get handed this like delightful IDE that's an abstraction of an abstraction of the abstraction. And so we thought it would be useful to kind of like examine exactly what's happening from you know, the bits on the wire all the way up to you know, how you interact with your browser. So when lots of people go to Starbucks, and I chose Starbucks because it's ubiquitous, they tend to get presented with a few choices of what network to join if they care to join a network. And one of them is ATT WiFi. This is an open network. It's everywhere. It's almost always free, but very occasionally you have to like click a thing or check into something. Here we have Capital Factory Guest, which is free. It does very much want you to authenticate, but that's trivially available. So today, ATT WiFi is basically a de facto coast-to-coast free open wireless network, right? At the particular Starbucks I was at, there were a couple others. There was TWC Wi-Fi and cable Wi-Fi, and then a couple others that looked funny that I didn't want anything to do with.
Linksys?
Linksys used to be the one. Linksys used to be the coast-to-coast, but now it's ATT Wi-Fi. And Linksys was by accident. ATT Wi-Fi is on purpose, right? So we're going to talk about what happens when you do open Wi-Fi association, right? This is assuming you've ever connected, for starters, to ATT Wi-Fi before. If you're on an iPhone or an iPad, I believe, and if it's from AT&T, by default, this will be a preferred network. The same is true on a lot of Android phones. And in fact, on some, I have like this library of crappy Android phones that I monkey around with, and sometimes it's like really hard to get it to not associate to AT&T Wi-Fi if it's nearby, which is really irritating. But basically, you open up and you say like, "Hey, is ATT Wi-Fi around? Because I've heard of that guy before." And one of the access points nearby will say, "Yep, that's me. I'm ATT Wi-Fi." And then your device will say, "I'm going to talk on your network. Is that all right with you?" It's the authentication phase, right? And the access point says, yeah, go nuts, let's talk. And then your device says, "Sweet, I'm totally going to start talking right now." And so it's like this little bit convoluted, just kind of like six-ish way handshake. And so you say, "Cool, I'm going to go ahead and join." The access point says, "Awesome, that sounds great to me." And now you're associated, right? And you're sitting in Starbucks and you're getting your things and everything's all great, right? So how do you know that you're on the same ATT Wi-Fi that everyone else is on? How do you know that you're on the same one that you were on yesterday? How do you know that you will be on the same one tomorrow? And on open Wi-Fi, you have nothing. There's no save in your operating system anywhere that says like, "Oh, well, this access point must have this hardware address, or it has to like have this kind of signal strength or be on this channel." All the AP says is like, "Yep, I'm ATT Wi-Fi. Come on in." The problem is that there is this whole class of attack called the evil twin attack. Evil twin is, like it says, somebody may have brought their own access point to that Starbucks that you're going to because they like know that developer nerds hang out there and they are building some awesome startup, and I would love to steal your startup before you're done building it, right? So maybe that happens, right? So you have alternatives to open Wi-Fi, of course. There's web secured networks. WEP stands for a wired equivalent privacy. The E does not stand for encryption. It stands for wired equivalent privacy. So you have the equivalent amount of privacy as if you were plugging into a wall. That's about all it's designed to give you. WEP is old-timey. You still see it sometimes if you happen to be the sort to go scanning around for networks. WEP networks are really valuable generally to attackers because it means that somebody at some point cared to secure it, that it's not open Wi-Fi, and it's really easily crackable like 4 or 5 different ways. So WEP stands out as like, please target me. I have something cool to hide, and I have like devices that I'm not ATT Wi-Fi, because that's lame. WPA2 is what we have today generally. The problem with WPA2, of course, is that many devices now come with this thing called WPS, which is wired something
secure setup, wired something.
Wireless protected setup, and
it's about as hard as associating a Wiimote to your router.
Right. So wireless protected setup. It's a standard that was introduced when it turned out WPA was really hard for people to do because you had like 15 different options, and maybe you're going to use one set of acronyms that you've never heard of or another set of acronyms you've never heard of. And you have like password requirements and all this other jazz. So WPS was an answer to that. WPS says when I want to connect to my network, I'm going to walk over to the device and I'm going to hit a button over there and I'm going to enter in a pin over here, something along those lines. It makes it really easy. It all boils down to this pin, like you have for an ATM. The pin is technically 8 digits, but the last digit is a checksum, so it's really 7 digits. And they are digits, it's 0 through 9. So this computers are super good at counting 0 through 9 a bunch of times, right? On nearly every network that I see these days, I'd say like 80% of them have WPS available, which makes it easy to brute force, so I can pop onto that network too. If I know that, then I can get the pre-shared key, and now I can replicate that device. WEP and WPS are okay for defending against the evil twin attack as long as like I'm not targeting you, right? Like if Trevor has WPS in his house, I can sit outside his house or set up a device kind of outside of his house, maybe a couple hundred feet away, and find out things about his home router and then replicate that out in the world and just kind of follow him around and make sure he's always associated with me. But it's real bad for like targeting random people or just like getting people onto your network, right? If you're a bad guy. I often speak of myself as a bad guy. I'm not a bad guy, but it's a useful rhetorical device.
Did you play one on TV?
I do. I have in fact played one on TV. So.
Did you include that link?
No, I didn't. We can put it up later. It's on YouTube. Yeah, I did this thing where I followed this reporter around for CNBC for like a day and just like was like stalking the hell out of him, and it was super creepy, and it totally violated the social contract. They followed both of you with a camera and had all this great music. Yeah, and I'm sure there were like lots of flying ones and zeros, like. Right, so that's what happens like when the radio on your, and it is a radio, the radio on your computer first wants to start talking on some network that's not like a cell network, right? But you're still kind of out of luck. Great, I've got the equivalent of a plugin. I'm on like plugged into the wall or whatever. But the thing that happens next is something called DHCP, right? And DHCP stands for the Dynamic Host Configuration Protocol. You almost always need this these days because people have these mobile devices that are super light and you can move them around from network to network. Very few people have static IP addresses or static addressing at all on their computer or their phone or their tablet or whatever, right? So DHCP says you need to use it in order to get an IP address. IP stands for the Internet Protocol. And so we'll talk about this a little bit.
Do you want me to move your slides while you draw?
No, that's okay. I can go back. That's easy. So right, so we've talked a little bit. So we'll just put up IP right here, right? So IP addresses are things that look like 1.2.3.4, right? They're 4 numbers. This is IPv4. I'm not going to talk about IPv6 today, even though that's another giant mess of problems. This is what IP addresses look like. There are special ones like 192, 168, something. There's a few classes of special ones, and these are generally the ones you're going to get. They're like kind of local. You never see these guys on the internet. You see them all the time when you're local. And you need DHCP to learn about your local network. You need to know we can get into it a little bit. I have actual screens coming up here. But you need to know things about your local network if you're going to talk on the rest of the internet, right? So this is what happens in the first 2 seconds. It's a little bit of an eye chart here, but basically this is packet captures from a tool called Wireshark. It used to be called Ethereal or Ethereal, if you never heard it said out loud. And so this all happens in the first 2 seconds. I'm going to look at each one of these to just kind of delineate where all these trust boundaries live and like how you do authentication and all that jazz, right? So the first thing you say is you come online. You come online and you say, you're you with your laptop, right? And you broadcast out to the world my Discover packet, right? That's what it's DHCP Discover, and you're saying, hey, where's the DHCP server at? Because I totally need that right now. All right, and you do this on the hardware, and you do this on the hardware broadcast address and on the IP broadcast address at the same time. That's what this is special right here. This This is how you notate hardware addresses, which we'll get into in a little bit, very soon actually. And then 255 is also, incidentally in hex, it's also FF. That is the general purpose broadcast address for IP, right? And so you say to the world, and by the world I mean ATT Wi-Fi, whatever your local network is, and you all did this when you connected to Cable Factory Guest, if you happen to connect to that one. You say, hey, I need to know what DHCP. On AT&T Wi-Fi in particular, this will cause the access point to shoot out an ARP, right? And so ARP is the address resolution protocol. This happens on a lower level than IP, right? So this happens ARP. And like we saw, they're usually things like DF, and there's 6 of those. These are nominally unique. They're supposed to be unique. Addresses assigned to every wireless card in the world. There's plenty of room.
The MAC address?
It is in fact the MAC address. And so ARP is the mechanism by which you learn other things' MAC addresses. It's real important to know, like, say, the MAC address of the router, for example. And it lets me know, like, if I want to talk to the router, how I go from an IP address of the router to the hardware address of the router, so I can talk directly to it. It's also entirely faith-based. Every reasonable operating system has tools for overwriting your MAC address. I can say I'm whatever MAC address I want, so I can cause problems if I decide that I'm your MAC address. And this is the usual way to, like, cheat hotels out of paying their $20 a day fees for IP. You associate, not that you should, because they work real hard at that.
Yeah.
But if all you do is connect up to the network, like we talked about, and then just listen for traffic, listen for broadcast, you're going to hear MAC addresses from other people who are already authenticated. So just go ahead and steal theirs. Don't steal theirs, because you'll knock them off and they'll have a bad day. Right? You should pay the $20, whatever it is. Right? So it's all based on MAC, which stands for the Media Access Control Address, which is that FFOC, OOD stuff, right? They're not signed. They can almost always be overwritten unless you're, like, on some really crappy hardware, and then, like, you can pretend that they're overwritten, but they're really not. And sometimes they happen gratuitously. Sometimes you have devices that just are on the network, and they will self-ARP. They'll say, like, hey, who has my MAC address? And then they'll reply to the broadcast, I have my MAC address. And this is great for people who, I guess, forget to ask, because that entry on many operating systems will go into your local ARP table. And so I can sit there, of course, if I'm a bad guy, I can just, like, go ahead and blast out, like, who has, and provide the answers. So without any interaction from you, right? So let's get back to DHCP. That was an interesting side note for what happens when you do ATT Wi-Fi. So we've gotten we've sent out the discover. We heard an ARP that seemed unrelated. And let me pop back here real quick. Sitting with the ARP, right? Yeah, we see this ARP and it's from 192.168.5.1, and it's ARPing for, can we see it? Oh yeah, it's ARPing for 5.249, right? I don't know who 5.249 is, but it just decided to ARP to it. So then at this point, we've sent out our discover, we got the ARP, and so then we get the offer back, right? And here's the AP, it's got a radio antenna like they all do, I guess. And it sends out, on this particular one, it sends out the offer on the broadcast. It broadcasts the whole thing. This is not normal. Most networks, other than ATT Wi-Fi, will unicast back, because it already knows what your MAC address is. Because you said, hey, I'm looking for the DHCP server, here's my MAC address, and it's from me. And so the access point will say to that particular hardware address, oh, here's where the DHCP server is, and here's the offer, right? On ATT Wi-Fi, for some reason, it just broadcasts out to everybody. So everybody can hear the offer that you just got to, right? And it offers a bunch of things. It offers like where the DHCP server is, where the router is, here's a domain name. And namely, here's your IP address, right? This is the big thing you need right now is an IP address, because otherwise you're out of the internet business. You can't talk. So it's offering 5.249, which is the same thing it just ARP for, like less than a second ago, or slightly less than a second ago. It also gives you other things you need. It gives you things like the DHCP server, which happens to be 5.1. It gives you the subnet mask, which is 255, 255, 255.0, which basically means everything before the 1, anything in that range, that's local. And that's all you got to know, is that it's local. If you want to talk to anybody in that, if you want to talk to anybody with this IP address, don't bother going to the router, it's all local. Outside of that, you got to go to the router. That's how that works. It's like the difference between ARP and and talking to the router, routing something over the internet, is like you call the Uber and Uber shows up and you say, I need to go to Phoenix, and Uber's like, I'm not driving you to Phoenix, but I will drive you to the airport. So it takes you to the airport, which is the router takes you to Phoenix, and then you land there, and then you call Uber again, and you're like, hey, I need to get to some address, and then some Uber car comes up, and you do that, right? So that's kind of the difference between local routing and network routing, right? It gives you the broadcast address, which basically you go with the subnet mask, and this all tells you like how to broadcast locally without having to do. It's almost always that. It gives you a bunch of other stuff that's super useful, right? And so we talked about this. The subnet lets you know what's local, what's remote. If me and Trevor are on the same network, I don't have to go through a router to talk to Trevor usually. And I know Trevor's IP address somehow. I can just make a direct connection, right? Tells you how to talk to the world, because it also tells you what the router address is, which is, in this case, 5.1, which is the same as the device. Tells you what the domain name server is, which is 5.1, which is the same as the device. This is all pretty normal for an access point. Access points tend to run all these services. They tend to run DHCP, DNS, routing, the radio that does all this stuff. It's not suspicious, actually. Right, so we talked about local and remote. If you don't know someone's IP address, which is how you start talking on the internet, you have to ask DNS, which is the domain name system. This is facebook.com or myspace.com or whatever, google.com or github.com. So basically anything that you can remember. Now, I know that there are probably people in this room that know GitHub's real IP address off the top of their head. You should know that in case DNS ever goes down. And that's a thing. Like, many people already know that like 8.8.8.8 is in Google's domain, for example. I used to work at Dell like a million years ago. I still know their IP addresses. Because DNS was not very reliable back then, right? So we've got the discover, we got the offer.
Hey, Todd, can you use black? Because I think it's hard to house.
Right. So the laptop says, and he's also doing this all over broadcast, because I don't know, Jack, because the offer came over broadcast, I'm going to respond over broadcast. I'm going to request that. I'm going to make a request. Right. I'm going to make a request. I'm going to say, yeah, I totally need an IP address in order to talk, and I need all this other stuff. I need a subnet mask, and I need to know a domain name, and I need whatever you think the domain name is. I need to know like what you think my host name should be. Here's a suggestion what I think it should be. And it's basically a reflection of what you just told me on the offer, right? By the way, like I said, this is all still broadcasting. This is all on FFFF, so everybody can hear this conversation. The final stage is the DSP App, right? And the app is, in normal cases, an acknowledgement from the DHCP server that says, yeah, you can have those. There's a whole state in here where I can request things and you can knack them, and and like, oh, okay, well, let me try again, because you were lying or something before, right? But now I have all the things I need, right? I know the router, I know where the domain name server is, I know how to look things up, I know how to convert from human readable to IP to ARP now. So I have all of these addressing schemes, right? DNS, so it goes kind of like, 1, 2, 3, right? And this whole thing takes about 1.5 seconds at this particular Starbucks on a Sunday afternoon, which was surprisingly busy. So it takes about 1.5 seconds. That seems like a very short amount of time. For computers, this is like a phenomenal amount of time. This is like 1,500 milliseconds, right? I can do tons in 1,500 milliseconds. And so who cares? On other networks in the same place, it took about 300 milliseconds, mainly because they didn't have that whole second-long pause for ARPing around for the address it's about to give me. That pause opens up ATT Wi-Fi to race conditions, where, like, if I'm a bad guy and I have my own DHCP server, I can totally beat the real ATT Wi-Fi. And I'm on that network. I'm not posing, you know, I've joined the real network, you joined the real network. I hear your request and I can jump in and give you an offer before ATT Wi-Fi does. And maybe I'll maybe I'll give you like a good, you know, I could give you a bogus IP and then you wouldn't be able to do anything, but what fun is that? Like, I could give you a bogus domain name server. I give you a bogus domain name server that resolves every name as you'd expect except for one. You know, like maybe your bank or something else, which we'll talk about it a little bit later. I don't want to give away any spoilers, right? But if a bad guy pretends to be DHCP, and even worse, I can pretend like I can give you a router that I control and ATT Wi-Fi doesn't. And that way, I'll get all your traffic, regardless of what you want to do, right? But how can you tell if you've gotten bad information? Well, it comes down to faith. You kind of have to just have faith that what you asked for and what you got match up to basically what everyone else got, right? So there you have it. I mean, you've configured your whole network stack kind of based on prayer that it's all right. And now I've done that, and now I'm going to ARP for the first time. This is my first real ARP, right, as a client. And I am ARP, in this case, Alpha is me, Portwell is the manufacturer of the AP that ATT Wi-Fi is on, and I ask, hey, who has 5.1? Tell 5.249, which is me. And then I get a response fairly quickly of 5.1 is at this MAC address. So now I know, and I do this because I need to know the router. At this case, actually, right now what I need to know is the DNS server, right? This will go in a table. Again, how do you know that the ARP reply is the real guy? Is it signed? Is it secure at all? No, it's all based on faith again. There are ways of implementing ARP security. There's tons. I count like 5 or 6. Like when you Google ARP authentication, you'll learn about AuthARP and SARP and ARPON and PARP and GARP and all this other stuff. As far as I know, no one in any network has ever implemented it. Like, if you know your network guys, or if you are a network guy, have you implemented any of these ever? Yeah, I've never run into any of this. And they don't all talk to each other, and they're not, some like GARP and SARP do talk a little bit to each other, but it falls apart pretty quick. And fixing ARP and fixing this like local hardware layer would require like changing the hardware, millions and millions and millions of chunks of hardware. It will never happen as long as we're on Internet v1, which is what we're on now. So that's a little depressing, I'm sorry. The good news, it's all local. I have to be kind of close, like physically. I can't do this while I'm sitting in China. I do have to have some kind of hardware nearby. And you can juice up your power and make Yagi antennas and be maybe a quarter mile away, but generally speaking, these kinds of attacks is going to be detectable by you have opened your laptop and about a second and a half later you hear evil cackling like 2 tables over, right? Or you look for the guy who's wearing gloves while he's typing, and it is pretty suspicious. Like when I was doing this, I had this kind of high power external antenna. I was running Linux, like criminals do. I had 3 or 4 scrolling windows of network traffic. I was looking pretty shady. Like if I saw me in there, I would immediately go over and ask him what he's doing and ask him if he wants a job and all that. So, my friend Roxy thinks I was not being that suspicious, but I don't know. I felt kind of suspicious. It's a very shady thing, but it's also very antisocial. Like even today, like I've been doing this forever, and I always feel a little like I'm I'm like wearing the X-ray specs and watching people in their underwear. Like they're not naked, but I'm watching. I can see through their clothes, like when they're doing this, you know. And you can listen for all kind of other broadcasty things. Like Windows does a bunch of goofiness for NetBIOS, and Apple devices like are always looking around for Bonjour. And then there's like the whole IPv6 thing, which is a whole other mess. But we're not going to really go into that too much right now because we only have one night. There are some reasonable defenses to this. Some of it's talked about in the README with getting a VPN set up. First and foremost, you're going to want to avoid open wireless if you can at all. You know, it should not be that high up in your. If you feel like connecting to open wireless, you should make that conscious decision. Yes, I'm on open wireless right now, and I know everything is about to get real shady real fast. If you're on open wireless and you're using VPN, which is virtual private networking, you have some cryptographic backing to all your traffic there. So even though you might have gotten lied to about the whole thing, if you have a reasonable VPN client and a reasonable VPN server, you'll be doing things like checking certificates. And so even if everything is all fake and it's all getting ported through, like the cryptography is still good. Like you can tell that the cert is for real, right? So even if all your names are totally bogus, you can still tell, you could then at least tell that it's working. Now, the problem with VPN is that it often doesn't work, especially when you're on some alien network you've never been on before. And what almost everyone does is like, my VPN's not working, I can't check my emails, I'll just turn off VPN. And now I'm gonna fail open. And this is how people generally operate. Very few people say like, VPN isn't working. Well, I guess I'm out of luck. You know, I gotta like interact with the people I'm with. You know, so, and that gets us to SSL. And when I say SSL, I really mean TLS. I really hope I mean TLS. I don't know if you heard, but SSL has been kind of taking a whooping lately. There was Heartbleed a few months ago. There was Poodle a few weeks ago. Just show of hands, anybody heard of the Poodles? Oh, goody, good. Because Heartbleed like got all the press, and then like the press has been kind of dropping off. We had this brief period where we were naming everything full names, and then we named something Poodles. Poodles, it is an acronym. It stands for something like, it's a cryptography article.
Oh.
Yeah, so you know what it is. So it's a little bit acronymy. But what Poodle did was it kind of was a nail in the coffin for SSL v3. Instead, now we're all supposed to be using the new TLS, and by new I mean introduced 14 to 15 years ago. SSL v3 is a holdover from days gone by where computing power was scarce and dinosaurs roamed the earth or whatever. But TLS stands for Transport Layer Security, whereas SSL stood for Secure Socket Layer. No one will say TLS for another 5 years, I'm sure. You know, casually in conversation, people are going to talk about SSL. Hopefully they mean TLS. There are ways to configure your web server and configure your client, and in fact, pretty soon, I think like less than a month now, Chrome and Firefox at least are going to be dropping, or Firefox may have dropped it already, SSL v3 support. So like you can't even talk to SSL v3 servers anymore. You must talk to TLS.
Firefox is dropping it later this month. I think Chrome already dropped it.
Okay.
Pretty much like within the day of Google. Really?
Yeah.
Okay.
So Transport Layer Security, or SSL, you need this to prove who you are. Very few people use the client certificates. It's super cool when you do, but nobody ever does it. It's mostly for servers. It proves that you as a web server who you are. You needed to keep the secrets. You need to, so like eavesdroppers on the network, which is actually not that common unless you're on open Wi-Fi. Eavesdroppers can't hear your conversation, namely that username and password conversation, or a session cookie, or something like that, where an attacker could take that and replay it and be you, right? And you need to ensure that your data is unaltered. So, like, if I'm giving you JavaScript in my HTML page, I want to know that you're running the thing I told you I was running. And so we do all this through certificate, and this is a GitHub certificate. I'm not going to show you the certificate because it's boring and it's all hex. But this is like the UI version of it, and it's very accessible to normal people because you all look at these like all the time, right? And this is GitHub certificate. The certificate is allowed to identify the remote computer, so github.com, and it would approve my identity. So like if I'm github.com, I could use this to prove that I'm github.com. And it does this other thing that doesn't have a mapping in my browser. I have no idea what that is, but it doesn't matter. All I care about is the identity of the remote computer here. And it's issued to github.com. And so basically what happens is that I get the certificate, the browser gets the certificate, it looks to see what I looked up on the DNS, right, which may be poisoned, and it matches up the name to the DNS name to the certificate name. And if they match, everything's gold. I know I'm talking to GitHub for sure. Right, so how do I know it's real? Well, I know it's real because this guy says it's real. We have this certificate chain, and this guy is a certificate authority named DigiCert. And who here has met someone from DigiCert? And oh, you have. Are they trustworthy?
Well, I said they have a big mouth, but who knows?
Okay. So this guy. So now we're like 2 degrees off from DigiCert. Hooray for us. It can come from any other authority, by the way. There's no like kind of secure and very secure. It's just 1 or 0, right? And so if you're on Windows 7, which I believe no one in this room is, you have 74 choices for a certificate authority. And if github.com cert is signed by any one of those 74, it is GitHub as far as your browser is concerned. On the other end of the spectrum, we have iOS 8, which has 3 extra certificate authorities that OS 10 Yosemite doesn't have. I don't know who those other 3 are.
You're saying OS 10.
Huh?
OS X.
Yes, that's right. OS X Yosemite has 220, iOS 8 has 223, and everybody else is kind of in the middle. Other Android versions is kind of a question mark because there are about 1 billion of them. Handset manufacturers, carriers, they'll drop their own certs in there, and because why not?
And that's not shady, right?
And it's not shady at all. And that's the thing, is that if you go and look at your list of certificate authorities, you'll find people like DigiCert and VeriSign and Enum and Thought.
Somebody's uncle at Huawei.
Yeah. Well, Huawei in particular is on OS 10 for sure. And so Huawei, which is a large networking manufacturer that is run by a bunch of ex-military guys from the People's Liberation Army of China.
By the way, if you graph like counterfeit MAC addresses, like for some reason Huawei beats everybody by like 3 orders of magnitude. They don't care. They apparently reuse them. Or maybe their stuff's getting counterfeited so hardcore that that's how all the MAC addresses get reused over and over again.
Probably, yeah. There's a lot of Huawei MAC addresses out on the internet, and hopefully those guys never like end up on the same network because they're going to have a bad time. Neither one of them are going to talk for very long. Well, one of them will win the race, and the other 10 won't. Right, and so we go from like DigiCert and VeriSign, which are like, good American companies, down to Huawei, and then down to the government. Lots of state government, like international state governments, have their own certificate authorities. Places like Spain and Italy and Greece are actually pretty big. Turkey and Qatar. And so if you happen to trust the government of Qatar, then and by default, your browser will. Feel free to like excise most of these, by the way, and have fun doing that. I have no idea how to do it on all the browsers.
Didn't Turkeys get duped before?
So Qatar was at one point issuing certs for star.star. So if you said you were anybody, it was legit, according to the government of Qatar, and that was an error. There are revocation certs, and there's a whole revocation scenario, but we're not going to get into that right now.
Any entity that can land a World Cup despite having an average temperature of 120 degrees in the summer, like, is somebody I really don't want to screw with.
That's true, and they generally are good at some things, but good at footballing does not mean good at issuing certificates.
I don't think anybody's going to be good at footballing at 120 degrees Fahrenheit.
So how does DigiCert know it's real, though, right? I mean, we know from this guy that they're golden, right? But how do they really know? Well, they have this really long 54-page document that describes how they find out. And it all boils down to section 141, which are the appropriate certificate uses, right? And the appropriate certificate uses say that the certificate issued under their auspices can be used for the purposes designated in the key usage and extended key usage field, because I had that extra one that I have no idea what it's for. So it's good for that one too. found in the certificate. However, the sensitivity of the information processed protected by the certificate varies greatly, and each relying party, that's you, must evaluate the application environment and associated risks before deciding on whether or not to use the certificate, which I'm sure you do every time you go to every HTTPS site, right? You do a thorough network audit every time. Say, hey, has something changed? Am I on a different network? Do I have a different gateway? Do I have a different domain name server? Are there new bad guys? You know? So really the onus is on you. They'll give you the cert, but it's on you to decide whether or not to use it. They also tell you what you're not allowed to use it for, like right next door, right, at 142. And it does not guarantee that the subject is trustworthy, honest, reputable in business dealings, compliant with any laws, safe to do business with. And the certificate only establishes that the information in the certificate was verified as reasonably correct when the certificate was issued. The code signing certs in particular don't indicate that the signed code is safe to install, is free from malware, bugs, or vulnerabilities. And that's what we pin our internet trust on. Are these certs, and every single one of them has a section like this of all the 220 or whatever they were. They tell you that, hey, use this cert if you want, and here's what you shouldn't use it for because, you know, got me. I have no idea why. And so that's kind of beginning to end, from opening your machine to talking to GitHub. There's a few places where that can fall apart, but we do it all the time, and it's okay, right? Because it's trust and it's faith, and we do have to have something there to or else we're just paralyzed, right? We're just paralyzed. So on to you, Trevor. We're going to talk about how to make money at this, right?
So I mean, at a certain point, like you're actually some of the people involved in that chain of trust, right? From the router up through the certificate authority, which kind of constitutes the chain of trust. They are incentivized. In the same way we talked earlier about society, like just you and I and society are incentivized to behave, they are incentivized to try to ensure their portion of those links of trust, right? I mean, if Starbucks starts getting a bunch of reports that like bad things are happening within the four walls of the Starbucks that Todd was at, then they might make a little bit of attempt to try to come down on that. If something happens and DigiCert gets owned or something like that, I mean, GitHub's going to change your certificate, blah, blah, blah. By the way, in the notes, I highly, highly recommend one of the things in the credits and resources section on the README for this talk, which is the talk from 2011's Blackhat, all about how certificate authorities work, why they're broken, and some potential alternatives. Those pretty interesting and well-regarded security researcher gives this talk, and it's great. It's YouTube. It's like 45 minutes. Anyway, so we want to end this without getting into like a whole bunch of sad paranoidness. So I want to talk a little bit about what we all do as developers, right? Because what Todd was just showing you is sort of what's happening as a user. But I would argue that no matter what, as a developer, you are selling trust. Some people have like real, scary, like high assurance jobs where like they're making sure that like when, somebody's insulin pump goes off, it's giving the right amount of insulin, or, when you press the gas pedal in your car, it actually revs the amount that it's supposed to, blah, 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 right? They're making like real physical systems where life and death is a real thing. But no matter what you get paid to do in computer software, you're selling trust. At the end of the day, there are people who are relying on you to make sure that your data has had some sort of reasonably prudent level of stewardship around it, that it's private, that it's accurate, that it's secure. So as developers, there are things that we can control and things that we must advocate for. And I'll take a step back for a second and say that I am not going to talk about public policy advocacy because I think that's a huge topic that's deserving of its own talk. I'd be more than happy to talk about that some other time. But when I talk about things that we can advocate for, I mean things that actually us as developers should be trying to make some noise about that directly involve our environments. So let's talk first about things that are under our control. A few examples are where JavaScript libraries come from, whether or not we encrypt the transport layer using TLS, what is kind of called SSL but is really called TLS, and whether or not we actively seek to find any security vulnerabilities in our code. So the first thing I want to look at is hot linking JavaScript libraries. How many people do something like this? Don't be shy. Yeah? All right. That's no problem. Okay. I mean, it could be, but this is, okay, so this is always potentially risky. You're bringing in JavaScript from an outside source, right? And the #1 classification of vulnerability for all web applications on the internet is cross-site scripting. Cross-site scripting is kind of very, very evil and terrible. And the problem with this particular thing here is not so much the hot linking of the JavaScript library, although there's some risk associated with that if your DNS is poisoned or something, and that end user is not getting the jQuery.com they think they are. The real problem is that this is not loaded over SSL. So you are not actually getting the benefit of any sort of authentication that the certificate for jQuery.com has been signed in as the real certificate for jQuery.com. At this point in time, when you're hot linking this in, you are implicating a whole huge chain of trust exists because you don't have an S at the end of that HTTP. Your users are you're taking it on faith that they're not compromised by some sort of like router problem. The jQuery.com hasn't been owned completely and something happened to the SSL certificate or whatever. I mean, keep in mind if jQuery.com did get owned, the guys don't need to change the SSL cert. They can still happily serve you an evil version of jQuery, which is why I recommend not ever doing this anyway. I know that at least for when this started happening like years ago, we were dealing with like much larger basic JavaScript libraries. And the CDN, the jQuery CDN had not been compromised before at that point in time. So I would submit that, and I'm sure that anybody who's really like profiled their traffic lately could maybe tell me that I'm full of it, but I would submit that you don't necessarily get a whole hell of a lot out of doing this. It's possible that under really high traffic loads like that, I'm talking out of my ass or something, but I would avoid doing this in general. Another thing I would do is I would consider using SSL everywhere. There was a thing a few years ago. I can't remember what the name of it was. It's basically a Firefox plugin that would allow you to just sort of double click on somebody's log Firesheep. Does everybody remember this? Yeah, like where you could just basically say like, oh, I see other people are logging into Facebook like on their, in the coffee shop. So it'll pop up, it'll show me all the traffic going through the network, and yeah, I'm gonna be that guy now. And now I'm using his version of his Facebook page. That did a great job of sort of waking people up to this general problem, and then suddenly like Facebook started using SSL and all of Google stuff went over SSL. Everything that GitHub does is over SSL. I would actually challenge people in here to come up with things that shouldn't go on SSL, because like with all things with information security, I can concoct a scenario in which you're wrong and it'd be horrifyingly bad even if like your PTA website was not on SSL or something like that, right? So that's kind of hyperbole, but also kind of not. Also, SSL is a lot cheaper to do than it used to be. So it's not, computationally intensive as much anymore because of like Moore's law and whatnot. And because of the preponderance of totally, rational and awesome, reputable CAs, we can always get a SSL cert. Use the static analysis tool. How many people use Rails right now for your job and use something like Brakeman? Okay, cool. Not a whole lot of people. I don't know. Maybe how about Rails for your job at all? Yeah. Okay. So there's like some overlap there. All right. So Brakeman's just like a good static analysis tool. If you have the money, Code Climate's pretty cool. It'll do Brakeman for you. And it's just part of the whole checkboxing of that Code Climate makes so nice. So there's just like several ways that, in this sort of sense of like being able to have some things under control and sort of do some best practice stuff that you might want to pay attention to.
So Brakeman looks for things like the mass assignment bug, right?
Yeah, it looks for known bugs in Rails, and it looks for things that are going to be sort of circumventing like Rails security stuff. Like I believe that if you just sort of drop your own forms in there without using form helpers that give you CSRF tokens, it'll give you shit about that. So what are some things that require our advocacy as developers? This one is sort of a little bit of advocacy, but actually some more just knowledge. Know what the hell OpenSSL is. Like, be aware of the fact that it's actually a fairly brittle, fairly old library worked on by like a half dozen people around the world. That is changing because of some of these big problems that have happened this year. I believe a consortium of sort of larger companies like Google and Facebook that depend a lot on open source tech have started to throw some of their money at trying to fix this problem. But it's good for everybody who's doing anything online to have like some basic understanding at the like diagrammy level of what encryption handshakes do and what's meant by cipher suite and things like that. And just realize what you're dealing with here. You're dealing with something that underpins most of the security on the internet and is entirely open source and occasionally has amazing facepalm bugs. I mean, just like holy crap kinds of things just pop up, and you don't know how long those were there. You don't know to what extent those have been exploited over the years. So hopefully, like I said, that kind of thing will be getting fixed pretty soon. This is kind of a hobby horse that we have like around our office. we make a lot of gems at Rapid7 for the Metasploit Framework, and we don't even sign our gems because verification doesn't happen at signing of gems, and signing of gems is not like super easy. It's not very widely used, as my kind of weird highlighting is here. I didn't just like put this in HTML, I actually screenshot it and drew on it. It's really painful. But think about that for a second. Most of you are in here using Macs, right? And all the latest version of OS 10, all the later, like last 3 versions since they put out the App Store, have like a 3-way security setting for the machine as a whole, right? You can install only things that come from the Mac App Store, which means they've been signed, the actual binary has been signed by Apple as being directly from Apple. Or the second switch is you can install things that came from an Apple certified developer, meaning that they issued them a certificate signed with their certificate, and then it's good to go and you've got some sort of short chain of trust going back there. Or you can install whatever the hell you want, which is probably what most of us do since we're developers and we have to install all kinds of things all the time. What I'm getting at is that the notion of signing software that you install is old and well understood and has been around for a long time. And if any of you were listening to the Ruby Rogues podcast a few weeks back that had, I can't remember his name, but he's like the kind of the main maintainer of Ruby Gems right now. Abdi Graham asked him, he's like, what's the state of signing with Ruby Gems? And effectively the answer was, I'm not very good at cryptography stuff and I don't want to make it like worse. So I would love to talk to people about this and work on this with somebody, but it's not a priority right now, right? And my contention is that the people like us should be making noise about this and should be trying to make this a priority. Because what happens right now is that I just have to have it on faith that whatever I roll into my build from rubygems.org is the gem, is the bits that the originator, that the author actually intended me to get. And that in that entire chain of transit, from their computer through Ruby Gems to my computer, every intervening router, every intervening piece of machinery, every person, everybody at the hosting company, everyone that anybody hired anywhere in there has not messed with that at all. Now, you're probably sitting here with a lot of skepticism going like, what are the chances of that? Well, what are the chances of you getting a wreck in your car on the way home tonight, right? Not super high necessarily. It doesn't keep you from putting your seatbelt on, right? I mean, these are the types of sort of questions we ask ourselves in this type of world. But I don't understand why this doesn't work better. We have a signing mechanism. It doesn't work. It's not easy to use. The community should get together and try to do something about that. But I gotta say, like, at least Ruby Gems cares a little bit. Node, like, aggressively doesn't give a shit. Like, it's sort of amazing. If you go to Node right now and you download the tarball of the Node package manager, you're not even offered a checksum. Like, and checksums are usually there to like sort of ensure like data integrity. They're not there to give you any sort of security guarantee like a signing of a binary is. They don't even have that. If you install stuff, you're going to get it over HTTP, not over SSL. So I really have to ask WTF, MTM, NPM, because it's not like it installs important things, right? I mean, this is running on Reveal.js, and I don't know if you know Reveal.js, but in order to have Reveal.js as a little speaker mode, you have to be running a local web server. And because anything that you do with JavaScript must, of course, be written in Node, because how dare you use like a Python or Ruby or Perl-based web server, we are going to be installing, when we type npm install in the Reveal.js directory, it will be installing whatever the hell it wants to, and one of the things it installs is a socket.io library. Since JavaScript doesn't come with socket.io, that's implemented as an external library. And so, I mean, I run Little Snitch as a, I run an outbound firewall on my machine, so like I have at least a reasonable understanding of like what sorts of external connections my computer might be making, and this Node process has yet to try one. But think about that, like I am installing the library that allows network connections to happen in Node, and I have absolutely no guarantees at any level of what that is, where it came from, or whether or not it functions as intended. None. Like not even that the server that I got it from is certified by this, CA thing as being real. That's weird. It's weird for us to rely on that. To extend that chain of trust all the way through to our clients, I would say is actually beyond risky and strays into the realm of being sort of derelict. So conclusions, because it's been a long talk. We know how human societies work for hundreds of years. We know like what their axiomatic kind of level of reliance is. We know like what they need in order to exist. But we also know the internet lacks those same constraints, right? So there's no social order, so the trust of those things doesn't make as much sense as it would in day-to-day life, right? So as a dev or an end user, you should just know what you're trusting. And do your best to shorten that chain of trust, and do your best to make sure that you can verify those links. As we said before, there's always going to be like some portion that you're going to have to trust. There's always going to be that double yellow line that you just got to trust that the guy is going to stay on the other side of the line, you're going to stay on the other side of the line, you're both going to get home tonight, right? So don't think of security as what to be afraid of. And this is, if you take kind of one thing away from this talk, please take this. It's too hard to fall down a paranoia rabbit hole. There's too many things to be afraid of. Like, it's like anything else. If you're, if you're targeted by a sufficiently advanced actor, there's not a lot you can do about it, right? If like the dude from Splinter Cell decided you needed to die, like you're screwed, right? I mean, like if the Chinese military wants to hack you, not a lot you can do about it other than the fact that your attack surface is pretty small because you've just got your home router and like whatever you derp around on the internet with. If the Chinese military decides to hack Lockheed Martin, unfortunately, there was not a lot they could do, it turned out. So, what we really need to do is think more less in terms of what to be afraid of and how to secure ourselves and how to get this bunker mentality. And really, I think it's just more empowering to think about how to sell a better trust product. We all think about how to sell the best possible thing that we can. We ought to think about how to give sort of empowerment and assurance to our users, to our customers, to our clients, that the trust product we're giving them is the best thing we can do. So that's it for the talk part of this. And I know we're kind of, we're at 8:15, so that's like an hour and change. So this was definitely billed as also like a venue for anybody to ask any question at all about networking or security. So we'd like to get into that right after this, but I also think it's best to give everybody like some time to take a break. So I have 8:12 right now. Should we go ahead and say like 8:25? We'll kind of like reconvene, and whoever wants to ask any questions can ask away, and then we'll do that through about 9 o'clock. Unless you wanted to go to CADA, Noah, but I don't know. Maybe I should first find out if anyone wants to talk about networking in depth after this, because if not, we could do a different thing or just go to the bar early. I'm not getting a lot of hands.
I want to talk about it.
Yeah, I know you always want to. But yeah, if there's not like a preponderance of questions, and if Noah has a CADA ready to go, we could roll with that, or we can just say screw it and go to the bar early.
It's like private questions that you're not.
Private questions.
Really interested.
Yeah. Are you taking the questions now?
Well, what I wanted to try to figure out is like, is there any point to like taking a break, going to the bathroom, coming back, and having the question time? Because if there's not, then we can like try to think of a different plan. We like to be fluid here at Austin.RB. So let's just go ahead and take a break, like 10-minute break, come back, and then whatever questions there are, there will be questions.
So how do you list your certificates?
I have a question. Flipping your cache between packet detector. Definitely.
Well, we're sponsoring the bar top, by the way. So there's 3 minutes if you stick it out.
So, yeah, it's been the timeout is set to 1.5 seconds. Oh, is there? And then it's failing within. And I don't know
Typically, it's a latency period of usually in the phone start looking for somebody else. Now this is great if you're back up, right? Because I can ensure I have power. That's dictated by legislation, not by physics. So I can put turns out like everybody. So that's a big list of what is the uppermost level, like what's the most decibels on wireless. So that's fine. If I have to in America, it's this much. And I am going to the FCC says how much you're allowed to do. Well, if I decide to tell my wireless card that I am Bolivian, I get all of them. Because Bolivia is the most liberal in the world. I get 1,000 decibels. So be Bolivian. You're going to attack people.
Hooray, Bolivia.
Yeah. So set your wireless and it's like a
We didn't even talk about, well, it's just,
Well, Holly asked me, I mean, as opposed to internship, I don't know if the permission is different. Like, because I've heard it mentioned in other things now, like internship. But I'm not sure. I don't know what the community is like. Missing two, but I don't know what it is. The only place that I don't is calling for some skill stuff, but that's different because they're like so they do software, hardware, and art. So So I'm not actually sure what the difference is. I did say that we have some ranges. Yes, I emphasize that a lot. I emphasize that we have a huge community and we're open source. Why I emphasize more that, like, I don't know, like, that's a benefit of, like, knowing your shit is actually being used as opposed to, like, yeah, somebody somewhere, some company is supposed to be looking at this. Come on. People know people are using it. No one said that. I don't want to scare newbies away, but, like, people are at it. It's pretty cool. Going through and just taking out all dirty, like smoothing snake making this be okay, considering how many millions of lines of code externally, that's pretty good. There's a software right now that is just like extracting commit messages. It's hilarious because I think most of them must be from open source games or something because they're like zombies will now no longer catch fires and exposed to food or something. They're like,
I guess I really haven't done this
Yeah, I think this is that was the first one.
Yes, yeah, really good extractor, which
use like a don't make that the primary. Don't reference that if you're trying to reference a user, it's like a random tree or something. So I can have a primary key that's like number one instructor, and have a separate key. I would just say that so instead of using like 1 to 1,000 starting at 1, kind of predictable, right? So you can reference user ID that
Okay. Who had questions or discussion points or whatever? Stump the presenter. Stump him.
When we were considering the coffee shop scenario, it was kind of mentioned, use a VPN or whatever. But suppose I'm just browsing and my endpoint has been compromised, server has been compromised, the certificate authority has been compromised. Is it safe to use TLS with the browser if I type in the address in my address field and not use a VPN?
Sure. So the question is, basically, if you're just doing networking like you normally do, right? No VPN. Is TLS good enough? And it is. I mean, if you assume that Qatar doesn't screw things up again, I mean, really the best thing you can do would be to take some time, and it's generally not hard in the browser to like get rid of certain certificate authorities. Like on Linux, it's super easy. It's just indirectly. It's like an Etsy SSL or something.
Yeah, same thing's true on Austin.
Yeah, so generally it's not hard to get rid of a service that you're never gonna like rely on all the time. Every once in a while you're gonna run into something and it'll say like, hey, the service isn't trusted. Are you sure you want to go on? And what that really is saying is that it's not that the cert is bad. It's just not in your certificate chain. It's just okay, right? Everything's cool. TLS by SSL by itself is the reasonable mechanism we have today for matching up domain names with like website content, and basically any content.
Yeah, so I think that's true. That's fine, right? But I mean, like I was talking to Gabriel back there, and he just brought up a good example of like, if you sit someplace and you win the DHCP race condition that he showed you, right? And so like as Todd was saying before, ATT Wi-Fi is not like something. It's like a big collection of known routers that are like known to your machine, and your machine is checking against that list. It's literally just the string ATT Wi-Fi, whatever that SSID is called, and that's what you're using to like get back in there, right? So think about the things that you do to get on the internet. Like you're tired, you're sitting in the airport, like, I gotta jump through this stupid hoop in order to get on the internet. Well, screw it, I have a corporate card, whatever, I'm not gonna get charged $20 for this thing. I'm gonna use the internet for 30 minutes in the airport this way or whatever, right? Like, you may end up, getting a page that looks just like the real thing for that airport or for AT&T Wi-Fi or whatever it is that you need to do to like authenticate and get in there. And you're so used to being confronted with these things. You're so used to like, oh, I have authenticated to a thing and oh, by the way, the router that at Hilton or whatever the hell that's forcing me to first, okay the charge is abusing this protocol stack in order to force you through that, right? I mean, they're basically doing the same thing that a bad guy would do, like to say, oh yeah, sure, except google.com goes right here right now, because that's where we need you to go in order to get your, give us your pound of flesh, right? So, I mean, in that specific way of talking about it, then yeah, if you're sitting on open Wi-Fi and you're only talking SSL to somebody and you've got a reason to trust the certs in the cert chain, then sure. But if you think about the way that it really usually happens in the real world, you could very well lose the DHCP race and then be in a position where you're getting served a page that looks real, you're putting in some information to it, and then bam, somebody's got your credit card number, right? Like, that's a very typical scenario for this type of thing, right? It's just say, like, I'm just gonna clone that page and then pretend to be that thing. Yes, Luke.
Are all the versions of WPA2 guaranteed to not disclose the password? Like, do they do multi-form hashing so that the server, if it was compromised, can't actually recover the password?
Unless WPS is enabled, which is most of the time. So the question is WPA2 good enough for password hashing, right? So like, I'm not giving up the actual password, I'm giving up a hash to the password.
Right.
Yeah.
No?
No.
No?
No. So cryptographically, yeah, the protocol doesn't have a way for you to recover the actual password, but every router ever stores it on disk somewhere. So if the router
that's not
actually
what I'm worried about that you're sending the password and it's not the real router, so it could get the password to the real router from you, if if it wasn't hashed.
If I'm pretending to be somebody's WPA2 router, they give me the password, they give me a hash. Do I get to
that's a challenge. That's a challenge response. So okay. No, you can't steal a WPA password that way by pretending to be a WPA2 router. access point. So that's
You can drive a key from enough recorded WPA traffic.
That's a different thing.
Not safe ever. Stop using computers. Yeah.
Computers are hard.
So I mean, well, even then, like it's just you can gather enough encrypted traffic, and then you can start doing.
Now, what you do give away so you have your list on your machine of like, here are the routers that I'm allowed that I want to connect to. When your Wi-Fi is on, what you are giving away is that list. You're giving away a list of names, and that may be like, if I see that you're asking for like Chronic's Death's awesome cable glory, then I know that it's you, right? I know it is. You'll and you can just see on Linux machines, it's pretty easy to like drop things in monitor mode. Now I can watch to see like what you're asking for, and it's all associated with MAC addresses. So now I can start building up profiles of like, well, these people talk to 2wire 248 a lot, and they both do, and maybe they know each other. And, I can start doing stuff like that, but I'm not stealing passwords.
Yeah. You do get interesting information though. Oh, yeah. Sorry, go ahead.
Yeah.
When my computer is searching for a Wi-Fi network, why is it broadcasting the names of anything? Why is it broadcasting SSID?
Because you have your list. You have a list of things you've associated to in the past that you've also said like always connect in the future. And so you're looking for those guys again. Because it doesn't, like, your computer doesn't talk to like your GPS and say like, well, I'm in Phoenix, so I'm not going to be nearby anything. Like, as long as your Wi-Fi is on, it's going to go through and it'll just loop over and over and over again. Like, hey, maybe I'm close now. Maybe I'm close now.
There's no other way to detect. I mean, can't you just like call it and say, hey, any access points in the area?
Yes, and that's step one usually. But a lot of times, what people do, especially today, they'll turn off beaconing on an AP, and so when you turn off beaconing, you also have to ask all the. So like an AP tends to send out beacons. It's like, I'm ATT Wi-Fi, I'm ATT Wi-Fi, and then you'll say, oh hey, cool, I will talk to you, and that's how it gets on your list. You used to have to like go through a lot of hoops to do this. You have to do like net sampler stuff, something. But generally, beaconing solves that. When people turn off beaconing, which is somewhat common in like kind of small medium business scenarios when they give a shit about the wireless. They'll turn off the beaconing, so I'm not getting out the SSID, and in order to discover that, you have to ask periodically. And it's usually like every 5 or 10 seconds.
So the end result is that's like a default behavior of a lot of clients.
Yes.
Well, and the problem that turning off beaconing was intended to solve, like not giving out the name of the network, is completely defeated by the fact that clients are asking.
Yeah. Clients nearby say, hey, am I near Secret HQ?
By the way, in case you didn't know, OS10 has a really easy to use monitor mode that you can throw all the things into if you want to. And you can watch like all the stuff happening. If anybody knows how to get it out of monitor mode without rebooting the box, please let me know. That's my help.
That's why I use external things.
Yeah, I have a computer so skinny and emo that I have to have a freaking dongle to use Ethernet. It's ridiculous. It's a bridge too far.
Because it touches itself at night.
So maybe but SS or TLS and caching on websites, right? It's like I'm not really clear about how that works. I always kind of had the impression that when I went SSL, then I couldn't cache on server-side caching, like with Varnish or what kind of caching is. Do we have to like put something in to like handle the endpoint on the server to decrypt it, and then we can cache, go into our caching?
Well, I think it depends on what you're caching. So, I
cache everything.
Right. I haven't implemented Varnish myself before, and I've actually been out of the like SaaS business for a few years now. Like we actually ship a Rails app in a Bitrock installer, which is the product that we sell. So I couldn't answer intelligently about Varnish in particular, but I would imagine due to the speed that we're seeing, most of these big sites run with, that like things that they need to cache in terms of just the usual things that you do with that. By the time, I don't know. It's a good question as to like what
cache
that
all your static stuff. That's trivial, right?
Yeah, you're always going to cache static stuff, which is like going to be quite a bit of what you're serving.
It's kind of really the basic part of that if we have everything is cached, we have Varnish up, right? That if we just simply went to HTTPS server, then we would lose all of that without making some other kind of
You can terminate your SSL before the large,
Right.
right?
You have to
Use like HA proxy or something to proxy your request through and just terminate your
You can
SSL.
terminate terminate the
That's what
SSL. That's the part that you have to do.
Right.
And that's going to defend against, your coffee shop eavesdropper. It'll defend against, like, your ISP. ATT is also known to inspect and sometimes alter content. If you ads for ATT. So you'll be defending against you're not defending against like the guy in your data center that's sitting between the SSL termination point and then your web server, but you're still like a way lower.
Yeah, the termination problem is why Google now doesn't terminate early. Is that the NSA was actually Google will terminate at one data center, transfer traffic to another data center, and snip it between what was in theory Google's own fiber. It wasn't internet fiber. But the fact that it went outside their building meant the NSA could have it. So if you terminate SSL early, you have to worry about who's listening in what is supposedly private servers talking to each other. Which if you're hosting on AWS, you have to worry about where the servers really are. Like even if they're between racks, they might not be secure. So it depends on what you're hosting, how secure you care that is.
Right.
And by the way, there's no there hasn't been some sort of fundamentally enormous advance in mathematics on the order of, cooler than splitting the atom, which is what it would take for NSA to actually cracked all of that stuff. But the internet was not designed with the notion of an actor that could record all traffic and then just come beat you over the head with these legally dubious warrants to get you to cough up the SSL search so you can decrypt it, right? So they can decrypt it, right? That's what's actually taking place. It's not that they've cracked encryption through the use of magic, right? That hasn't happened. They're just, they record all traffic in their gigantic data centers.
Maybe they have, but the evidence of the secret warrants and what Snowden is saying is implying that they haven't actually done math magic.
Probably the minimum safe key length, though, is higher than we think.
Well, we also know that they've been attempting to weaken ciphers through the
elliptical curve.
Yeah.
And we also know that they, I don't know if anybody saw this the other day, they still continue to publish guidelines with a straight face on how to build
number generators.
Right, on how to build random number generators. Exactly, you saw those things. Yeah, they're like, here you go, this is the way we think you should build random number generators. It's cool, I'll take your advice on that now, especially since I know you're
That's the thing, is that the NSA does have two missions. And the guidance on random number generators supposedly comes from that side of the NSA that is very interested in
Sure, I'm sure the right hand didn't know what the left hand is doing.
Sure. But that's the thing, they have this problem. I'm sure they don't consider it a problem, but I kind of consider it a problem that they have two missions. They have the inspection mission and then they have the secure mission.
Related to secure number generators, I can't remember which one Ruby uses, but Python uses the merge and twister unless they change the restate, and that is not cryptographically secure. The difference between actual secure random number generator, which is secure random in Ruby's standard library, and the fast random number generator, which is the pseudo random number generator.
So Dogecoin.
Yes.
I think Ruby does the right thing, and I've looked for OpenSSL and asked OpenSSL when it's not available. Like, hey, Ruby at least from your random did something really crazy.
Yeah.
Right, so just be very aware when it falls back.
Yeah.
Kaminsky, I think, had a talk at Defcon about this, about always be aware when you're going to do fallback.
Other questions?
Also, as NSA could be that they're uncertified.
Oh yeah.
Out of the server.
I don't know that we in the United States, lots of United States government agencies have certain authorities, and the NSA subpoenas things in known courts and these crazy un-American secret court things that we have now post 9/11 as well. So where you're not really allowed to find out why they want it or whether you tell anyone you've been asked for it, right? So
the current workaround, if you think you're going to be a large popular company, the Rails app is implement a canary.
Yeah.
Because you can't say you were asked to disclose something, but you can publish a web page that you take down after what.
You can say I've never been asked, and then when you do get asked, you take it down. That's what Apple did, right? So that's Apple almost certainly was the target of a recent subpoena because they put a warrant canary into their TOS a while back, and then somebody's gone. So do with that information what you will, right?
Question?
Yeah, so have you guys done anything or know anybody doing anything in the space of like big data and like vulnerability analysis? Like,
oh yeah. Oh yeah. Yeah, we do that at our company. So HD, who's HD Moore is local. He founded the Metasploit Framework. He is now our director of research at Rapid7. So we actually have a thing called Project Sonar, and with Project Sonar in partnership with a group at the University of Michigan, we scan the internet, the entire public IPv4 space every few hours. And that's only on a few ports, right? But it's very specific stuff that we're kind of scanning and versioning. So it's 80, it's 443, it's some Windows-oriented stuff, whatever. And we do that and we version it, and it's an unholy quantity of data. And we get all sorts of interesting stuff out of there. For instance, there have been times when we've seen an SSL certificate change, and for like a large entity on the internet. And you know, that's could be a clue that that entity was breached and they changed the SSL cert, but they're just not telling anybody.
They haven't gotten around.
They haven't gotten around to telling people. They don't want to alarm anyone. But yeah, I mean, it's a different kind of big data. Like throwing things at it like Hadoop or something like is sort of less useful because we don't care about it relationally in the same way. Like we might take it to that level at some point, but we are actually it's in these weird specialized sorted string databases. Because it's I don't know, I think the total Sonar data set right now is up to like 600 or 700 terabytes for all of the versioning that's been going on over like 16 months. But yeah, so we do that. There's things like Shodan. I don't really know if Shodan is like really specifically geared toward phones, but kind of.
I mean, Shodan it's a banner searcher basically. It's Google for banners, and not just HTTP banners, I want to say, but mostly HTTP banners is what people use it for. They use Shodan to do things like find people's security cameras that are on the internet by accident, which is delightfully fun.
Yeah, and then
if you can watch people park like 24 hours a day, it's awesome.
And we have a cloud product at Rapid7 called User Insight, and User Insight effectively is like a kind of a combination of log file analyzer and like heuristic rule box, pretty much. So what it does is it sort of it's like an intrusion detection system for user behavior. So instead of like watching like what IP addresses are like talking to each other, we're watching what users are talking to what. So a classic vector of attack, if you break into a network as a bad actor or as a pretend bad guy, a white hat hacker, penetration tester, or whatever, is to find some credentials and then start replaying them in other places. There's a thing that's hilarious that security people are used to, but I find it infinitely hilarious. It's called pass the hash. And pass the hash, turns out that Windows networking protocols will allow a hash to be used as a password. So like, if I like compromise your Postgres server and I steal your Rails app like salted hashed password, right? I can't really replay that. I could put it into a cracker and like try to crack it, but I couldn't like take that thing and turn on a log right back into your system with it. With Windows networking, you can. And that's turned off or mitigated or whatever in certain versions, later versions of Windows, but it's kind of like always going to be there. So if you get onto a machine and say like 2 years ago your IT guy installed some like local admin thing and you got full access to this box and it's the same account and password that he used in like several other places, I don't need his password. I can just grab the local hash out of the store where the hashes live on the local machine. I can just pass it around the network and log into stuff all day long as the administrator, right? So if you're a person who's in a big organization and you've got access to like 4 or 5 different systems though, and you try logging into like something you've never logged into before, our system will look at that kind of thing and flag on it, right? If you try to exfiltrate, like, today, like your data from your computer to Dropbox or Box.net or AWS or whatever, we deal with a bunch of different logs and interactions. Suddenly you move 70 gigs up there and you've never done more than 5 megabytes in a day. Like this will flag you, right? That kind of thing. So it kind of shuts down that vector of attack. And as of a year ago, when we were first like betaing this internally, we were just tracking Rapid7 employees, and Rapid7 about a year ago had just under 300 employees. And that system was generating over 1 billion events a day for us, for the 300 employees. And now we have several pretty large customers on User Insight. It's been a big product for about a year now. We have an entire like DevOps operations team for it and all that other stuff. So I don't even know how much we're doing now, but it's large. I mean, we have a big RabbitMQ cluster. We've got a whole big Hadoop standard setup and all that. So we do big data stuff on that level, and we also do this big scanning of the internet too. Cool. Anything else?
I have another question.
Sure.
So I'm working on trying to figure out a way to do like a secret service, get like our secrets in at the last possible second at runtime for like some Rails applications.
Mm-hmm.
Are there any tricks to making that happen? I mean, I know it's like kind of hard to get at runtime, but like what's the closest y'all have gotten?
Well, actually, the thing you're about is once they're in there, is how many copies do you have splattered over memory once they're in there? Because it turns out it's really hard to stop VMs from copying. VM as in like the language game of Ruby or the Java JVM from scanning your secret in multiple locations. There's a blog post recently about how hard it is to get the encryption libraries and the JVM to not scatter your stuff everywhere. And considering how much more work the JVM has had, it's likely Ruby scatters your secret in multiple locations. So even if you inject it late, you're not going to inject it into secured memory. So like secret memory is like, I won't allow this memory to get written back out to disk when like the VM gets powered down and hibernates or something like that. I think that's what you have to worry about more about injecting as late as possible is the fact that it's going to be, you're going to have a lot of copies of your secret somewhere in memory or on disk probably, unless you set up secret memory.
Right. Okay. But like getting like the closest point to like, at runtime, pulling my
probably the closest place to do agent-based, the way that like SSH agent works, where it's over like a local IPC, where it's asking another server that can only be contacted locally. You set up so these servers can only talk, you don't talk to anyone else, and asking it for the secret securely. There's stuff for setting this up about so that you like keep the password for like any search that require a password. Search for that, and you'll see how to set this sort of thing up.
Okay, cool.
Very few people realize as well that you actually have more control over the environment, right? Like you're not going to Roku or something. Like Linux has this whole suite of like kernel cryptographic retention services, right? Where you can say like, no, you're the kernel. You keep a hold of this for me. You make like apply restrictions and say, okay, you only make it available to people who access this keyring and so forth. And it'll hold like X5 of client certs and all sorts of stuff in there. The API is actually pretty reasonable to program against. So if it's really that important, there's actually a whole suite of stuff the OS might offer you that is actually really useful. If you need that.
Yeah.
It is. So,
What was that one?
I think it's like kernel key retention services. Like there's a text top documents in the Linux source code that you can go look at. And not much stuff makes use of it. It's been around forever.
Oh, cool. Nothing much uses it, and it's been around forever.
What was that?
Impossible.
This sounds like a...
Nothing much uses it, but it's been around forever.
And it guarantees something about security. I'm sure it's bug free.
Yeah, I know that.
Any other questions? Anything?
An announcement. That's all right.
Announcement. Go for it.
All right. So EFF Austin, sort of a local electronic frontier foundation. It's doing monthly meetups here at Capital Factory on third Mondays.
Oh, cool.
And actually, so next week, Todd Manning is going to be speaking about privacy and security, the
All right.
things. So if you're interested in that sort of stuff and the kind of laughability of that and stuff that I think these days, that'd be a good one.
Yeah, he did a bunch of really fun hacking of the GoPro. He did this whole talk about it at Defcon. The GoPro has like way more shit in there than you would think. The GoPro does a whole has Apache running on it and like everything, right?
Yeah.
Yeah, it's like an old BusyBox Linux machine or something with with like a half dozen sort of services on there. It's all ludicrously insecure, but it's so you can control it yourself. But yeah, that sounds awesome. Todd's a great guy. Y'all should go to that. Anything else?
You guys are not in South Austin?
No, we started doing the monthly meetups it's a good space for it.
Yeah, for sure. That's the week, is that the Thanksgiving week, Monday?
I don't know, third Monday.
Okay. Anybody else? No? All right, it's 10 to 9. Should we go to the bar? Let's go to the bar. And the bar.